Hi everybody! So in today's video we're going to be talking about different features that we can look for on a graph. For example, suppose that the following line shows the height of a balloon as it loses air and drops to the ground. So if we look at this as the balloon starts kind of up here and it starts to slowly drop to the ground over a certain amount of time. One of the questions I might be interested in is how high above the ground was the balloon before it started? So when it started means at the beginning. If I look at this graph, the beginning would be here on the y-axis. So I would say that the height of the balloon was 8, and I can use these units, feet, above the ground before it began to descend. Another question I might be interested in is when does the balloon hit the ground? So hitting the ground would be intersecting the x-axis, which would be at 4, and I can use these units here, minutes. These two features, the place where the graph intersects the y-axis and the place where the graph intersects the x-axis, are called the y-intercept and the x-intercept. And they're very helpful in real-world situations for describing what's happening. So oftentimes we need to know where those locations occur. This is going to teach us how to find those two specific places on a graph. So let's start with some vocabulary. The x-intercept is the location where a graph crosses the x-axis. It's the place where the value of y is 0. I should have written this in red, I apologize. I should have corresponded to my previous picture. Is the place where the value of y is 0. For example, if I look at this x-intercept, the coordinates of that point would be the point 1, 0. So the y value in this ordered pair is 0. And that's always going to happen. For any point on the x-axis, the y value is going to be 0. The y-intercept is the place where the graph crosses the y-axis. So that would be, for example, right here on this graph. The coordinates of that point would be 0, -2. So we often say that it's the place where the value of x is 0. And the value of x will always be 0 for the y-intercept. We care about x and y-intercepts because they usually help us describe important features in real-world situations. For example, it might help us determine how high was a balloon or where did it land. So let's practice looking at some graphs and finding the x and y intercepts. So in this first graph right here, I would look for the x-intercept on the x-axis. So here's the x-axis. It's the place where the line crosses through that point. That would be at the point 1, 0. The y-intercept would be the place where the graph crosses the y-axis, which would be at the point 0, -2. If we try this again, the x-intercept of this graph would be also at 1, 0, and the y-intercept would be at 0, 3. Another thing we might have to do, instead of looking at a graph, is use an equation to find these values. So we need to remember that the x-intercept is the place where y is equal to 0, and the y-intercept is the place where x is equal to 0. I always think about it that if I want to find x, then y should be nothing, should be 0. If I want to find y, then x should be nothing, should be 0. So we can do this by using substitution. So let's find the x-intercept first. To find the x-intercept, I would take my equation, which I already had, which was 2x plus 7y equals 28, and I would replace the y with 0. So my new equation would be this, 2x plus 7 times 0 equals 28. Now if I simplify this, 7 times 0 is 0. So my real equation that I have here is 2x equals 28. I know how to solve that, which I already learned, and that would be by dividing by 2 on both sides. So x would be 14. In my ordered pair, I would say x is 14 and y is 0. If I wanted to find my y-intercept using an equation, I need to remember that my x is 0. So I'm starting with the same equation as before, 2x plus 7y equals 28. I'm going to replace my x with 0. So my new equation will be 2 times 0 plus 7y equals 28. Now 2 times 0 is 0. So I would just have 7y equals 28, which I know how to solve. To solve that, I would just divide by 7 on both sides, and I would get y equals 4. So now I know that my y value is 4, and my x value is 0. So I would write 0, 4. Let's try that one more time. So in problem number 4, we're going to find the x and the y-intercept. To find the x-intercept, I need to remember that this is the place where y is 0. So I would take my equation, 3x plus 2y equals 6, and I'm going to replace the y with 0. So I would have 3x plus 2 times 0 equals 6. Now 2 times 0 is just 0. So I would just have 3x equals 6, and I know how to solve that. I would just divide by 3 on both sides, and I would get 2. Now to write my ordered pair, in my ordered pair the x would be 2 and the y would be 0. If I wanted to also find my y-intercept, this is the place where x is 0. So I would take my same original equation, 3x plus 2y equals 6, and I'm going to replace the x with 0. So I would have 3 times 0 plus 2y equals 6. 3 times 0 is 0. So I would have 2y equals 6, which means I could just divide by 2 on both sides, and I would get y equals 3. In my ordered pair, I would say x is 0 and y is 3. The last way we might be asked to find an x and a y-intercept is by looking at a table of values. So we need to remember that the x-intercept is the place where y is 0, and the y-intercept is the place where x is 0. In the table, y is 0 with this ordered pair. So my x-intercept would be -1, 0 because of this 0 right here. The place in the table where x is 0 would be here because the x value is 0. So my y-intercept would be 0, 3. I can do the same thing in the next table. So the x-intercept is the place where y is 0. In this table, the value of y is 0 right here. So I would have -1, 0 as my ordered pair. And the place where x is 0 is right here. So I would have 0, -7 as my ordered pair. All right, that's it. Thank you guys so much for watching. Have a great afternoon, and I will see you tomorrow for some more practice.